Hello everyone, good evening. Good evening. Good evening, Lokesh. So today we will start Turing machines. A small part of context-free grammars is remaining. We'll finish that. This is the QR code of my compiler design textbook. This will be helpful for BTech, MTech and GATE. And if you have not bought it, please buy it from PW store. And this is my Telegram channel QR code where the discussions happen every day. So you can join our Telegram channel. This is the QR code. Okay. Fine. So today we are going to start Turing machines. Today we are going to start Turing machines. And before starting Turing machines, there is a small portion of context-free grammars remaining. We will finish it. Okay. So if you have a grammar like this, A derives A alpha or beta. This is an example of left recursive grammar because leftmost symbol is equal to LHS. Leftmost symbol in the RHS is equal to LHS. So this is an example of leftmost left recursive grammar. Now the problem with left recursive grammar is this is not allowed by any top-down parsers. Okay. The reason is A is calling A without checking anything, right? Now how can I convert it into right recursive grammar? So can I write like this? A derives alpha A or beta. Will it convert the language into right recursive grammar? So when you are saying that this is the right recursive grammar for this left recursive grammar, you have to see that the language generated by this left recursive grammar is equal to language generated by this right recursive grammar. Okay. Do one thing, find out what is the language generated by the left recursive grammar and the right recursive grammar. Find out what is the language generated by left recursive grammar and right recursive grammar. Okay. Find out what is the language generated by left recursive grammar and right recursive grammar. So just find out what is the language generated by the left recursive grammar and what is the language generated by the right recursive grammar. Okay. Then you will understand that whether they are equal or not. Hi Mohit. So now if you see the language generated by this, A derives A alpha, A derives A alpha, A derives A alpha or beta or beta, right? So the language generated by this is beta alpha star. If you look at the right recursive grammar, if you look at the right recursive grammar, this is going to generate alpha A, beta, which means this is generating alpha star beta. So the languages are different. So you cannot write this left recursive grammar as directly right recursive grammar, right? You have to generate this language, right? Use without using left recursion. How can I generate that? How can I generate that? So I can write like this: A derives beta A dash, and A dash has to derive alpha star. I can write a right recursive. A dash derives alpha A dash or epsilon. This is how you eliminate the left recursion from a grammar. This is how you eliminate the left recursion from a grammar. Okay. Okay. So today actually I'm not feeling well. Okay. So we will do class only for little time. Okay. So when you have A derives alpha, A derives A alpha 1 or A alpha 2 or A alpha 3, so on, A alpha n or beta 1, beta 2, beta 3, so on, beta n, so on, beta n, so on, beta n. Now, how can you convert this left recursive grammar into right recursive grammar? So, we are going to write A derives beta 1 A dash or beta 2 A dash or beta 3 A dash, so on, beta n A dash. Now, A dash derives alpha 1 A dash or alpha 2 A dash, so on, alpha n A dash or epsilon. So for this left recursive grammar, this is the equivalent right recursive grammar, right? Now let us see. Now let us see. Now let us see what is non-deterministic grammar. Okay. What is non-deterministic grammar? So when you have A derives alpha beta 1 or alpha beta 3, beta 2 or alpha beta 3. So the initial part of different productions are same. Now this will lead to backtracking, because if you want to derive alpha beta 3, first you will check this, then you will check this, you will backtrack, and then finally you get to alpha beta 3, right? So the problem with non-deterministic grammar is backtracking, right? And most of the parsers cannot work with this. Most of the parsers cannot work with backtracking, right? So what we do is we will do left factoring for this grammar. I will write it like this: A derives alpha A dash, and then A dash derives beta 1 or beta 2 or beta 3. Okay. So we will start a compiler design from Turing machine from tomorrow. Okay. We will end this session here. Today I am not feeling well. Okay.